Python has multiple data types and data structures that you can use to store and manipulate data efficiently. In this video, we will discuss the Python data type memoryview. Hey everyone, welcome back. Today, we're exploring one of Python's more advanced but incredibly powerful data structures, memoryview. If you're working with large data buffers, binary data, or performance-critical applications, this tool can make a big difference. Let's dive in. Memoryview is a built-in Python type that allows you to access the memory of another object, like a byte array, or array, without copying it. Think of memoryview as a window into the memory of your data, so you can view and modify it efficiently. When you're working with large data sets or binary files, copying data back and forth is expensive. Python normally makes a copy when slicing or converting data. Memoryview lets you manipulate or read slices of data without creating a copy. It's especially useful in performance-critical or low-level tasks, like working with network buffers, image data, or shared memory in multiprocessing. Memoryview is ideal when you need to work with parts of large data blocks without copying, when you're doing binary I/O or network programming, when you're using NumPy, array, or struct modules, and when you're building high-performance or memory-efficient applications. It's especially helpful when you're interfacing with low-level data formats or writing efficient data processing pipelines. Here are some things to keep in mind. Memoryview supports bytes, byte array, and other buffer-compatible types. Its zero-copy changes to the view affect the original data. You can slice, index, or even cast memory views. It supports multidimensional views with the right underlying data. And it's immutable if the source is immutable, like bytes, and mutable if the source is mutable, like byte array. Let's take a look at how we can use memoryview in practice. In this example, we create a memory view of a byte array. We can then view just a slice of the memory view. We can modify portions of the memory view. We can create a memory view from an array. Once we have the memory view, we can cast it to bytes. While casting, we can actually create multi-dimensional data structures. Here, we create a byte array of the range from 0 to 16. Then, using the cast method of memoryview, we make it into a 4x4 matrix. We can access any element of the matrix using the appropriate indices. Notice in all of these examples, we didn't create any new data. We just looked into and worked with the data that was already in memory. So that's your quick guide to Python's memoryview. It's a powerful tool for advanced Python users, perfect for cases where performance, memory efficiency, or binary level manipulation is required. If this helped demystify memoryview, give the video a like, subscribe for more Python deep dives, and let us know in the comments how you'd use memoryview in your projects. Thanks for watching, and as always, happy coding!